Now we're going to look at polyatomic ions. And what polyatomic ions are, what the name implies. The word or the prefix poly means many, atomic, referring to atoms, and ions are positive or negative charged atoms. So polyatomic ions are many atoms put together with a charge. Okay, so a polyatomic ion is a group of covalently bonded atoms that have a positive or negative charge. So if you think back, covalent bonds are between nonmetals. So we're talking about atoms that are nonmetals that are bonded together, they're sharing their electrons, and they have a charge. Okay, now the important thing here is that they act as a single unit. Okay, and I'll show you what that means. So if we have multiple atoms bonded together, now they act as a single separate group, almost as if they are monoatomic, meaning they have one atom with a charge. Okay, so over here on the left, we've got what we call a hydroxide ion. And what you notice is that there's an oxygen and a hydrogen. Remember that oxygen is a nonmetal, hydrogen is a nonmetal, and these two nonmetals are sharing electrons. Okay, so this is a covalent bond. Now, because I have a covalent bond, and the key here is that they have a charge, this is what makes it an ion. Okay, covalently bonded atoms with a charge become ions, specifically polyatomic ions. Okay, so this is what we call a hydroxide ion. Over here on the right, I've got nitrogen, which is a nonmetal, and I've got 1, 2, 3, 4 hydrogens, which are all also nonmetals, and they're bonded together, they're sharing their electrons. Okay, but the key here is that they have a charge. Okay, so I've got a group of nonmetals bonded together covalently, and they have a charge, which makes it an ion. We would call this an ammonium ion. Okay, so how are you supposed to know where these come from? Well, if you look at your periodic table, back, all right, here we are. So some important things to know about polyatomic ions is that we're going to use them just like normal ions. Okay, so just like before when we used our positive and negative charges, when we did the crisscross method, the same rules apply. Okay, now because these polyatomic ions act as a single unit, we are never going to change the original subscripts. Okay, what we'll do is we'll use parentheses to kind of protect those polyatomic ions. Okay, and I'll show you what I mean here in a moment. So the parts of a polyatomic ion, you've got CO3 and a 2 minus, and remember I said that this can also be written as a -2. The -2 in this area up here is the charge. Is the charge of our ion. Okay, the 3 at the bottom, this 3 right here, this is my subscript, and the subscript tells me how many of those atoms I have. So in other words, when I look at this, I know that the 1 for carbon is implied. I've got 1 carbon, 3 oxygens, and combined they have a -2 charge. Okay, let's look over here to the right. So using your reference chart, the section that I just showed you, the polyatomic ions, I want you to find the following polyatomic ions, and I want you to write the formula for those ions. So I'll go ahead and stop here, pause the video, find these 4 polyatomic ions on your list, and write the formula for each. Okay, let's go ahead and pick up. Looking at our polyatomic ion list, you were looking for chromate. Chromate is the 6th polyatomic ion listed, and the formula for chromate is CrO4 with a -2 charge, or 2 minus, however you'd like to write it. Acetate, there are two formulas for acetate. The first one is C2H3O2, all bonded together, there's no spacing in between, all with a -1 charge. Okay, or you could have written it CH3COO, again, all bonded together, no spaces, with a -1 charge. Either one is acceptable. I prefer writing it this way. I think it's easier to remember this way. Okay, nitrate. If you look further down the list, it's all in alphabetical order. Find nitrate, not to be confused with nitrite. There are two different formulas. Nitrate is NO3, so 1 nitrogen, 3 oxygens, and combined they've got a -1 charge. And the last one is phosphate, now down towards the bottom of your reference chart. Phosphate includes a phosphorus atom and an oxygen atom, 4 oxygen atoms to be exact, and that ion, that group of covalently bonded nonmetals, has a -3 charge. All right, now let's look at the left side. We're referring to the diagrams that we saw up above. It says write the formula for the ammonium ion. So the ammonium ion was here on the right, and you notice there is 1 nitrogen surrounded by 1, 2, 3, 4 hydrogens. So I would start off with the nitrogen in the middle. We'll list first, and there were 4 hydrogens, and combined y'all saw it had a +1 charge. And if you look on your periodic table on the reference chart and you find ammonium, it's written NH4 plus, meaning NH4 plus 1. So what is the charge of ammonium? Well, we just said it. It's a +1 charge. What is the subscript for nitrogen? There's no number written below nitrogen, so it's implied that it's a 1. But when you look at hydrogen, hydrogen has a 4 attached to it as a subscript, meaning there are 4 hydrogens. So what is the formula for the hydroxide ion? Well, if you look at hydroxide, it's got an O and an H bonded together with a negative charge. So the formula for a hydroxide ion, and you can even look on your polyatomic ion list, is simply OH with a -1 charge. So let's go back. Okay, moving forward. So now, how do we use the crisscross method with polyatomic ions? So remember we said up above that they act as a single unit. So we're going to use parentheses to protect our polyatomic ions, especially if the subscript that we're giving it is greater than 1. If it's 1, we don't need parentheses. If it's greater than 1, meaning 2 or higher, then we need to protect it with parentheses. So let's start with ammonium and oxygen. So ammonium is your polyatomic ion. Okay? Oxygen is a nonmetal. So on your reference chart, find ammonium. It's the second polyatomic ion listed, and the formula for ammonium is NH4 with a +1 charge. Okay, oxygen, you'll have to look back on the periodic table on the front side. We know the symbol is O. Oxygen is in group 16, therefore it's got 6 valence electrons. It's looking to pick up 2 more. So when it does, it's going to become charged with a -2. And now I do the crisscross method. So I'm going to only cross the numbers, not the charges. So the 1 from ammonium is going to come over here to oxygen, and the 2 for oxygen is going to come over here to ammonia. Okay? So what you end up with, I'm going to rewrite it. I get NH4, and I'm bringing the 2. I forgot to add the 2 before. I'm going to bring the 2 down. Now, 2 times 4 is 8, but I don't multiply them in this case. When I'm writing my formula, I'm going to protect my polyatomic ion. I cannot change the subscripts. So what I need around my ion, because 2 is greater than 1, I need parentheses. So I'm going to put parentheses around NH4, and then I'm going to add the 2 outside the parentheses. And then I'll add my oxygen with a subscript of 1, and like I've mentioned before plenty of times, you don't need to write the 1. So NH4 in parentheses with a 2 as a subscript, and then an O with a 1 that's implied here. So this is your formula for ammonium and oxygen. So what do we call that? Well, we always list the full name of the polyatomic ion according to our rules. So since the polyatomic ion is listed first, then we list the first full name of that ion, which is ammonium. And then our rules apply for oxygen. I lose the ending and add IDE, and it becomes ammonium oxide. All right, looking down at the next one, calcium and hydroxide. Calcium is a metal. A hydroxide is on your polyatomic ion list. We talked about it on the previous slide. It is a polyatomic ion. So that automatically makes this an ionic compound. So let's start the crisscross method. Calcium is Ca. Calcium is in group 2, so it's got a positive 2 charge. Find hydroxide on your polyatomic ion list. Okay, it's in alphabetical order down with the H's. It's written OH. It's a a hydrogen and an oxygen bonded together with a negative charge. So now I'm going to crisscross. I'm going to take the 1 and transfer it down here to calcium, and the 2 for calcium comes down here to hydroxide. Just like that. Now I combine them. So calcium is going to get a 1, hydroxide. The hydroxide ion doesn't have any subscripts. So if I add any subscripts to it, like this 2 is greater than 1, I have to protect my hydroxide ion with parentheses. So parentheses around the hydroxide, and the 2 goes on the outside of it. So I get CaOH2. Now remember, we don't need this 1 here, it's implied. So what you end up with is CaOH2. So what do we call this? Well, using your rules, the first full name of the metal, and I have one, it's calcium, so I'm going to write it as calcium. And then the full name of the polyatomic ion. There's no changing the name of the polyatomic ion. In this case, it's hydroxide, so I'd write it as hydroxide. So I have calcium hydroxide as my name. And my last one is between aluminum and phosphate. So aluminum is a metal. Phosphate is a polyatomic ion, and it's on your list. The more familiar you are with your polyatomic ions, the easier the naming and the writing of the formulas is going to be. Because you might see this phosphate and you might think it's referring to phosphorus by itself. Well, that's not the case. Yes, it has phosphorus in it, but it's also bonded with an oxygen. It's a polyatomic ion. Be familiar with these. So we'll start with the symbol for aluminum, Al. Aluminum's in group 13. Group 13 elements have a +3 charge. Phosphate, it's on our polyatomic ion list. It's written as PO 4 with a -3 charge. Okay, remember, phosphate is not just phosphorus. It's a phosphorus with 4 oxygens bonded to it. So now I do the crisscross method. So the 3 comes down here, and this 3 comes over here. So when I rewrite this, I get Al3 PO4, and 3 is greater than 1, so I have to protect my ion by putting in parentheses, and the 3 goes outside of it. So Al3 PO4 3. Now, this is an ionic compound, and what's unique about these is they're telling me a ratio, which means I can reduce. So look at your new subscripts. You have a 3 and a 3. Remember, we cannot change the polyatomic subscripts, but we can change these. So 3 and 3, I can reduce those. I can simplify them both by dividing by 3. And what you end up with is Al1 PO4 1. Now the 1s are implied, so I do not need to write them. More commonly, you'll see them written as AlPO4. Aluminum bonded with a phosphate ion. So what do we call that? Well, the full name of the metal is aluminum. And it's got a polyatomic ion, so I need the full name of the polyatomic ion as well. And that's phosphate. Aluminum phosphate. There we go. Charts that are at your tables currently, flip over to the back side of your periodic table, and you have a chart that looks like this. Okay? Now, all those polyatomic ions can be found in this section right here. This entire section is where we're going to find our polyatomic ions. Okay, so we're going to be using this section as a reference from here on out. So you'll need to make sure that you know where to find them. Okay, if you haven't grabbed your periodic table by now and you're just listening to me talk, please grab your periodic table and look to the back side and find this highlighted section, because I'm not going to be able to go back and forth every single time. Okay, so now that you've got your periodic table and you flipped to the back where all these polyatomic ions are, you'll notice that there's an entire list of them. Okay, from acetate all the way down to sulfite. All right, now with the exception of acetate, every other polyatomic ion has one formula. Okay, acetate has 2 formulas. The one that I like to use the most is the second one, CH3COO minus. Now notice that every single one of these formulas has a charge. This one has a -1. This one has a +1, a -2, a -1, -1, -2. So sometimes you'll notice that they'll write the negative symbol after the number. Okay, or sometimes they'll just write the positive symbol by itself or a negative symbol by itself. Okay, if there's just a symbol by itself with no number, it's implied that it's a 1. Okay, if I zoom in here a little bit, you'll notice that NH4 plus is the same thing as writing NH4 plus 1. Now over here, carbonate, it says CO3 2 minus. The same thing can be written as CO3 minus 2. Okay, for ClO3 with a minus symbol, it's implied that it's a 1. Okay, so just keep in mind that it could be written multiple ways. CrO4 2 minus can be written as -2. Okay, so some things to keep in mind. Okay, that's our list of polyatomic ions.